across a variety of disciplines. So what is Learn or what is R and why should you learn it? Well, it is a programming language used for data analyses, statistics, and visualization. It is used across various fields, including STEM disciplines like biology, engineering, computer science, humanities such as sociology and psychology, and even professional areas like business analytics and marketing. So no matter what major you're in, you can probably apply R to your own skills, and it will be useful to you later on. And learning R empowers you to analyze your own data effectively and make informed data-driven decisions. So within the slide, I also included a variety of companies that do use R. So they have data analysts or business analysts that use R within their own companies. Just to name a few, Google, Microsoft, Amazon, Facebook, or Meta now also uses R. So moving along, for today's workshop, there are three things that were in the email. So I asked you ahead of time to download two data sets. One is called Shark Attacks and one is called Personality. So while I'm explaining the slide, if you haven't already downloaded that, I encourage you to do that now. For today's workshop, you did not have to have R downloaded at all, and I didn't encourage you to do so because there's a few specific steps I wanted to go over together. So for the entirety of the workshop, I'll be sharing my screen, and you can follow along using a Google Collabs link that I provided in the email, and that I'll also provide in the chat again in case you don't already have it up. So R, to download it, it is completely free, which is great. And I provided a link both in the reference sheet and in the slide today on an easy place to download R. So I'm going to bring us to that right now. So I'll stop sharing my screen for just a second while I bring up that link. And again, you're not downloading it right now. I'm just showing you how to do so. All right, so now we are on the website that was on the slide. It's also in your R reference sheet for if you want to download it later. But there are two things to download when downloading R. And the website really clearly states it out. The first step is to install R. So when you install R, you're downloading the program, and then you will install R Studio. So the difference between the two and the reason why you need both is because R is more of the programming language versus R Studio is an integrated development environment, which makes R easier to use. So once you download R, you don't have to open it up. You just go ahead and download R Studio. And this is download R Studio Desktop for Windows. And if you don't have Windows, if you have a different system, you can scroll down on the website. And there are different versions you can use according to whatever operating system you have on your own computer. So again, we're not downloading this right now, just showing you for later when you want to download. So just to say it one more time, you're downloading these both in the order that first installing R and then R Studio. Okay, so now the next thing we're going to do is I'm going to stop share and share my screen again. Going to share. All right, so the next thing I just brought up is the Google Colab link that you received in your emails. If you don't have this up or if you can't find that for whatever reason, I am going to put that in the chat for everyone. So copy and paste that link. And what this is Google created a tool for all of us to view the code for the workshop today, all at the same time, even without downloading R. And what's really cool is that for each of these, we're going to call them blocks of code. When I am coding in R, you can go ahead and press the play button, and in live time, you can see the output when I'm explaining the code today. So for those of you that don't have dual monitors or screens, you can go ahead and just view my screen when I'm sharing RStudio and the code I'm writing. You don't have to view these both at the same time. But if you do have the ability to do so, you can play along with the code while I explain everything today. So the very first thing we are going to do is so that you all can follow along using this Google Collabs, is we are going to navigate to the table of contents here to the left. So it's just these three dots and three lines here to the left, and we are going to click on it. And now that we are here in the table of contents on the left, we are going to navigate all the way down to this file icon. And yours probably only has sample data in the file icon. So if you don't see personality data and shark data right here, what we're going to have to do is upload those data sets so your code actually runs in Google. So one more time, we clicked on Table of Contents. The upload to session storage icon. And once you click on that, wherever these two data sets are located within your own computer, you can click on them and click open to have them uploaded to this Google Colab. So just one more time, what I did was table of contents, navigated to the files icon, and then click upload, and you can upload those data sets. So I'll give you all just a moment to do that. All right. And for anyone who missed it, one last time, table of contents, files, and then we're going to upload these. Perfect. So like I mentioned before, you're just going to follow along using this. You can click play ahead of time while I'm explaining to see what output comes out. But I'll be explaining everything on RStudio. So I'll stop sharing and I'll start sharing my R script. And share RStudio. All right, and if I could get a pair of thumbs up just to make sure you all can now see a white screen with a lot of code in it. In the upper right, it says RStudio. Perfect. Thank you all so much. So this is what RStudio looks like. Like I said before, when you download both, you only have to open up RStudio because that makes everything much more visually appealing and easy for us to use. So the very first thing I'm going to show you is how to open up a script. A script is where we're going to put our code into. So when you open RStudio, yours won't look like mine because I already have everything open and uploaded. But the first thing you do is go to File, New File, and you can open something called an R script to contain the code you want to write. So just to explain what we have on the screen here, up here, this is called your source. So this is where you're going to write the script for your code. And whenever I write any code here, let's say 1 plus 1, and I want to run it, I can highlight it and then click the Run button right here. And so if I execute a command and I click one, oh, then my answer, 1 plus 1, appears down here in the console. The answer is 2. So moving away from the console, we can also see up here something called environment. And they're just the data sets and variables that I've loaded so far up here in the environment. We won't have to worry too much about that today. And down here, you can find a bunch of different elements as well. So you can find all your files, your plots. We're going to have plots later today, packages, which I'll also be explaining today. And there's also something called help, where if you don't know a word to this computer, all right, I'm going to navigate back to R. Okay, So now that I navigated back to R, just in case, I'm going to stop share and share my screen again. Okay. So now that we are back to R, this is an R notebook, and I enjoy using this because instead of seeing my output down here in the console, if I type my 1+1 command here, I can press this play button right here, and then voila, I get my output right underneath where I wrote my code. So visually, I enjoy notebooks better. Up here, these are just a bunch of instructions on how to make a new chunk of code. So if I had new code that I wanted to write and separate from the code I already wrote, it says here I can type Control-Alt-I, and then I have a new chunk of code just for organization purposes, and I can click the play button and my output comes out here. So we're going to navigate to the scripts that I already gave you in the Google Colab slides. And the very first thing we are going to learn about is how R works, what is its language or grammar or syntax. So if I wanted to do something very basic like calculate what 1+1 is, I couldn't tell R, please calculate 1+1. And the reason why is R isn't that intelligent. It's not at that point yet where I can just type something like that into it and something will run. So if I try to run this line, it will give me an error. It says, which is really nice because it's telling us, hey, I have no idea what you're telling me right now. So we have to talk in its language or syntax. And for R, if we want to do something like addition or use it as a calculator, it has specific syntax. So thankfully, it's a bit intuitive. You can use the plus symbol for addition, and I can say, okay, my code that I'm writing is 1+1, and I only want to run that one line of code. So I can highlight it, and then I can go up here and I can press run selected lines if I want to run just that one line. And there we go. Since it's a notebook, we get our output right here, and it's the number 2. So another thing to learn about is comments in R. Sometimes you write hundreds and hundreds of lines of code and you don't remember what each of them do. So what you can add is these green comments. If you see, I labeled what this code block is doing, what each line is doing as well. But we don't want R to read what these comments are doing or else the line of code won't work. For example, I got rid of this symbol right here and I ran this line of code, R would give me an error. It says, I don't know what you want with this addition thing because it's not part of the syntax or language that R understands. So you can add, suppose we call it a hashtag in front of each comment that you want to write. So you can literally write anything you want after the hashtag. I could write all of that and I could run that code. And because I put that hashtag in front of it, R will completely ignore it. So that is for you to keep track of what each of your lines of code do. That way you don't get confused once you have hundreds of lines of code. So we already went over addition. We don't need any kind of equal sign. We can just write it as it is. For subtraction, pretty intuitive as well. You can put a minus sign and let's run that line. So we highlight it, go up to run here, select line, and there you go. 3 is the answer. For multiplication, a little less intuitive. You put an asterisk, you can run that singular line. We get the number 24, and then division, and our answer is 5. So I only ran these one by one to show you specifically what each of these lines are doing. But let's say you had 20 lines of code and you're like, hey, I just want to run them all at once. So let's go over. So we have our chunk of code in this gray area, and we can click on this play button right here, run current chunk, and it will give us all of our numbers all at once. So you don't have to highlight it and run them one by one. And if you see these little ones here, you already know 4 + 5 is 9. It's not 1. Like, why do these ones appear? Well, you have one thing that you're running per line, so it's showing you, hey, the first thing that's outputted for 4 plus 5 is 9. Like you're only asking R to do one thing per line, so you're going to get this one to show you that, oh, this is the first element within the thing you're asking R to do. So focus more on here and ignore the ones for your output. So moving along, we are going to learn how to create variables. So a variable is sort of like a box or a container that holds information that can be used later. So if I can name a variable anything, I can name it box container, I can name it my own name, Stephanie, I can name it anything I want because it's just a name. And so here what you see is I created a variable named Stephanie. And the way you create a variable, I'm going to write it out here. So if I want to name one Stephanie, but I want to store information into that container or variable named Stephanie, then I can use this symbol right here, the less than symbol, and then put a dash next to it. So it almost looks like an arrow pointing to the container Stephanie. And then I tell it what information I want inside of there. So in this case, we can do an example called grad admissions. So maybe on Monday, I got accepted into one school. Tuesday, I got accepted into two. Thursday, I got accepted into five. And Friday, I got accepted into five more. So what happens when I run this one line of code? Again, we're just going to highlight that, go up here and run selected lines to run just one line of code. And our output, nothing came out. So why is that so? It's because we only told R that we wanted to store this information into this container. So we're not telling R explicitly, hey, we want to see what's inside the container. So in order to do that, I'm going to delete this line now since it's down here. We're going to use something called a function. So a function is a tool you can use in R to do something you'd like. So a function, an example of a function to see what's inside of our container is called print. So print will print out what's inside our variable as long as you put the variable name within the parentheses. So if I put Stephanie inside print, I can run the singular line, and then there you go. We can see what we stored inside the Stephanie variable. So 5 plus 5 plus 2 plus 1 gives us 13. So when we print whatever's in the variable, R will give us exactly that. So let's make it a little more complex. Let's look at Bob's grad admissions. Let's say on a Wednesday, Bob got into 4 grad schools. On a Thursday, he got into 5, and then eventually he got into 2 more. So the first thing we do is create the variable or container, and then we make our arrow that points to what information is being stored inside of there. And like I mentioned before, we can do 4 plus 5 plus 2, and then we can run that line of code. And again, nothing comes out in our output because we're only telling our, hey, store this information inside our variable. I'm going to delete this now that I typed it out for you all. And then we have our function, so we can write print, and we want our variable inside the print function so we know exactly what's inside of it. And again, I'm going to delete it now that I wrote it out for all of you. And I'm going to run that one singular line, so I highlighted it, and I'm clicking on Run Selected Lines, and we get 11. So what if we wanted to see who got into more or less schools? Well, we could create a variable called difference, and then we have our arrow pointing towards what goes inside this difference variable. And we can subtract Bob from Stephanie and run that one line. And we get no output because we're just creating a variable. And then we're going to use our print function to tell us exactly what the difference in the number of admissions are between Bob and Stephanie. And we got the number 2. So that is how you create a variable. And moving along, We are going to learn how to create vectors. So what if we have different lists of data or things we want to organize? Well, a vector is a list of things that are all of the same type. So what does that mean? Well, there are three different types of vectors. There are character vectors, numeric vectors, and logical vectors. So character vector, think of anything with letters like a name or a label that you want to put in. So if we wanted to look at attendance today, we would make a character vector, which just means a list of things within our variable. So I'm going to write the same code we have down below. So let's say I want to make a variable called attendance. We're going to use our little arrow, and then we're going to have to use the concatenate function. And so to concatenate means to link things together. So since we want to link all these things into a list, we can use C for concatenate. And then we can type in different names. So I could type in, let's see, the ones I can just see now, Sabrina. And you're going to have to put quotations around it because that just happens to be the syntax or grammar to create a character list in R. And sometimes these things are intuitive, sometimes they're just come from memory eventually over time after learning it once. And then I'm going to use another name from the chat. All right. And that is how we can make a list of names. So I'm going to delete this one now since we have it down below. And I'm going to run our line of code here, attendance, run selected lines. And we got nothing yet, so we're going to print out that line for who is in attendance, and it gives us exactly that. John, Alice, Sarah, and Miguel are in attendance. Now, if we had numbers, we could make a vector with numbers. Thankfully, we don't have to make any quotations around them. So we made our variable. We point towards what we want to put in our variable ages. We use C to concatenate or link together all the different lists of elements within our vector. And you can just write numbers as they are. So I'm going to run that singular line of code, run selected lines, and R doesn't give us anything because we're just telling it store this information into this variable. So there we go. We run it and we get our ages. And the very last thing we're going to learn how to do today, we won't go into too much depth about it, is you can make a logical vector. So the only two values you can have in a logical vector are true and false in all caps. So they have to be capitalized. And you might want to have a logical vector when you're looking, for example, at who passed a course. Is it true that they passed a course, or is it false that they passed a course? And having this true and false format can help with certain analyses. So you can say, okay, like someone passed it, that's a true, someone didn't, that's a false, true, false, and you can put that all into a logical vector. So same format, got our variable, we got our arrow pointing to our variable. We're going to use C to concatenate or link together all the different things within our vector or list. And we're going to run these two lines at the same time because I think you guys get at this point that you can run one line or multiple lines. So we're going to run them both. And we see that we get our information that we stored inside our vector. So now moving along, we're going to make our own variable and we're going to call it pizza. So I am going to delete these ingredients. All right. So we're going to create our own variable called pizza, and I'm going to ask you, the audience, to engage with me to help me create this variable. So we already have it written out. Pizza is our variable. We have our arrow pointing towards it to tell it exactly what we want within our pizza. And we have our C for concatenate when we link all of our ingredients together. So if I can have let's see, 1, 2, 3, 4 volunteers from the audience unmute themselves and tell me what ingredient they would like in their pizza.
Pepperoni.
All right, pepperoni is our first one.
Mushrooms?
Mushrooms. Good choice. All right, two more. All right, anyone, two more ingredients.
Olives.
Olives. And just to put the last one in, I think this pizza might need some cheese. So I'll go ahead and pull that in. Thank you to the volunteers. So we have our four different ingredients, and these are words or characters. So that's why we put these quotation marks outside of them. And we're going to run these two lines. So we're storing these these characters into our variable, and we're going to print out to see what's inside our pizza. So there you go. Our pizza is made of pepperoni, mushrooms, olives, and cheese. So what if we have multiple lists, but we don't want to view the lists one at a time? We'd rather have them all together within a data frame. Well, to make a data frame, we're going to use the function data.frame to combine our multiple vectors. So we're going to put the information we want into these parentheses. And so what if we want a data frame called pizza orders? So we're going to create a variable to name our data frame called pizza underscore orders. I could put pizza space orders because R doesn't like that for whatever reason. You see it's already giving me an X. So to link those two words together, I'm going to put an underscore. But again, you could literally name this whatever you want and it'd still work as long as you don't have a space. All right, pizza underscore orders, and then we're going to use our data frame function to say that, hey, these are the things we want within our data frame. So we first have a character list. We're going to call it customer and concatenate all our customer names together, Alex, Bob, and Charlie. And then perhaps our pizza type as well. So veggie, pepperoni, margarita, and our slice count as well. Do we want 8 slices in that pizza, 12, 10? And once you have all your information in, if you remember, there's a parentheses here that was open, and we're going to close it down here now that we have all three of our lists. And something else to note, after adding each list, we separated them by having a comma at the end of each of these lists. And since slices was our very last list, you don't need an additional comma here. Oh, yep, we have a question in the chat. Go ahead.
So if we want to put something into a list, that's when we use the equal sign, right?
Um, Yeah, you could use an equals, yes. So when creating the data frame here, sorry for not explaining that, we can go ahead and use an equal sign here. Before, when we were making them one at a time, we were just using like, hey, assign the variable here. But yes, thank you for pointing that out. Here within the data frame, when we're creating our lists, we can go ahead and use the equal sign. I think sometimes you can use them interchangeably, except typically in R, when you're creating them one at a time, or typically when you're creating a variable, it's better to use the arrow, as I call it.
Okay, that makes
Mhm.
sense. Thank you.
Yep. So we're going to go ahead and run this entire chunk of code, or actually just these lines. So run and run selected lines. And when we run our data frame, instead of seeing them one at a time like before, as we saw up here with our logical vector, we see them all more like an Excel-like format. We see all of our lists at once, which is really helpful information. So we have our customers, Alex, Bob, and Charlie, our pizza type, and our slices as well. So moving along, now we are going to look at a data set. So what if we don't want to create a data set like we did, but what if we already have one that we want to analyze? So my code chunk might be a little bit different from the Google Colab at this point because I have to read in the data a different way. If you remember for Google Colab, we clicked the upload button and we just uploaded it to our Google Colab sheet. But since I'm on R, I have to tell it where exactly I want it to find my specific data sheet. So we will be looking at the shark attacks data sheet. And there's this data set that was either created or collected a long time ago, and people noticed, hey, they're like shark attacks. The more there also seem to be a lot of ice cream sales. Are one causing the other, is what a lot of people were asking themselves based on this data set. Intuitively, the answer would be no, but we're going to take a look at this data and see why some people started thinking that. So to read in a data set in R, there are a few different ways to do that. Some people like to manually upload it in R, but today I'm going to show you the way I like to do it. So the first thing you're going to do is you're going to create a variable name for your data set. You can name it anything you want. I want to name it shark data, and you have to keep this consistent throughout for R to recognize what data set you're pulling. And so again, I can't put shark space data or else it really doesn't like that and it's trying to read two different functions or variables. So I'm going to put an underscore to link those two words together. And I'm going to have my arrow. And then I'm going to use a function. I'm going to write it up here. It's called read.csv. And I'm using read.csv because at the end of my file name, I know that Shark Attacks is a CSV file. Sometimes you'll have a text file, sometimes you'll have an Excel file. In the R reference sheet that I created for you all, I have a different function for each of those for you to refer to or reference to. And if that list is, it's not all exhaustive. So if you have a different type of data sheet that you don't know the command to, you can always Google, hey, what is the command to open up a text file versus another file? So we're going to use read.csv since that's the type of file Shark Attacks is. And within our commands, you can see that I have in quotations. This is a syntax thing or a grammar thing within R. In order to read in a file path, you have to use quotations. And I just told it the exact path to my specific file. So it's within my users, downloads, folder, and it gets us all the way to my file name. So if you haven't found a file path before to a file in your computer, I can show you all that very quickly. So I'm going to stop sharing my screen and open up my File Explorer, our workshop. And this is a bit different depending on your computer. I know that for Mac it can be different. Let's see. Share, File Explorer. All right, I'm going to drag that up. Okay, so in my own File Explorer, I remember where I downloaded my data sheets to. I put it in a file called R Workshop. For you all who downloaded it today, it's probably in the downloads section of your computer. And this part is a little bit different depending if you use Windows, if you use a Mac, but you can easily Google, how do I find a file path to my files in my computer? So at least for me on my Windows, I can hover over my data set. So Shark Attacks is what we're looking at. And I can left click right here. And then zoom panel's in the way. And then I find something called copy as path. So that's how I find the path to my file, and I can click on that. And like I said, this is different on different computers, so maybe it's something you have to Google on your own time. So I'm going to stop share and navigate to R now that I've copied that path. R Studio. Okay, so now I am back at R. And so if I just pasted, using Commands V or anything, if I just pasted that file path, I actually get those quotations already, which is really nice. But as you can see up here, the dashes or slashes are facing one way, and when I just paste it, they're facing another way. So this is another syntax thing in R where we have to do something specific for it to understand what we want. So if I were just copying and pasting this file path, I would have to change the direction of all these slashes and able for it to read in what my data path is. So I did that real quick. And I would put that into my read.csv function as I did above. So if I want to take a look at what this data looks like, I can go ahead and I can just run this first line to store all my data into this variable. So I'm going to run that first line. Nothing comes out because I'm just creating my variable. And we can use that same print function that we've been using all along to see what exactly is inside our data set. So I'm going to scroll down a bit, and R gives us this really nice visual of what our data set looks like. So these are our columns. We have the year, the month, the number of shark attacks during the year and month, the temperature, and ice cream sales as well. And R gives us some information as well. It says we have 84 rows, so it's not displaying all 84 rows. So instead, if I want to see the next amount of rows, I can click here and I can see more and more rows, and it goes all the way 9 pages long until I have my very last rows. So looking at this data the way we're looking at it now, it's very difficult to draw any conclusions about the relationship between shark attacks and ice cream sales. So the very first thing we're going to learn how to do is use the plot function. So it looks like plot, and we have our parentheses. So we are going to create a scatter plot using plot. So very first thing that we are going to do, I'm just going to write out exactly what is down below for you all to see how we create it. So we named our variable for our data set shark_data. So the first thing I'm going to do is, well, I already know for my plot, a plot has an X and a Y axis, and I want to look at shark attacks and ice cream sales. There are a few ways to do it, but the most intuitive to me is first we write out what our data set is, shark data, and then if I want to get one specific column, like ice cream sales, I'm going to put a $sign to show, hey, I want to grab a column for my shark_data. And so what's really nice is R, as you can see, is already telling me what columns there are, so I don't have to write it out. I can just click on it. So the first thing I want to look at is ice cream sales on my x-axis, and then I'm going to use a comma to separate my y. So what do I want on y? I want shark attacks, so I have to first put in what data set we're pulling on. And as you can see, R is already writing that out for me, so I can press enter or click. And I want to pull a column from my data set. So we're going to put the money sign, and then we're going to grab shark attacks. Now I want to add a few more elements to my X and Y axes and scatter plots. So to do that, I'm going to put a comma underneath or right next to my X and Y, and I'm going to press enter. And R will already make a tab right here for me, just to organize everything I'm writing a bit better. And I want to add X and Y labels to my scatter plot. So this part is a bit intuitive. XLab means X label equals. And because it's a label, we can put an equal sign right here. We're not going to use our arrows. And then since we're putting in a name or a label of that, we're going to put our quotation marks. And for our X label, we can put ice cream sales because that's what we put for our X up here. Ice cream sales. And then we are going to put a comma after that because we want to add more information to our scatter plot. So we're next going to put Y label or Y lab equals shark attacks. And we want to add another element to our scatter plot. We want a title. And so whenever you're making a title in a plot, you're going to use the word main equals, and then whatever you want to name your scatter plot overall. So we're going to say ice cream sales versus shark attacks. And I'm going to delete this now that I wrote it for you all because we have it right here down below. And we're going to highlight these lines and see what our plot looks like. All right, so we have our main label, ice cream sales versus shark attacks, as we wrote down here. We have our label on our X and our Y and X axes as well. And just looking at the scatter plot visual, at least to me, nothing really seems like there's a trend going on. Like when we look at the dots, which are plots of each individual data point, it doesn't seem like there's a trend. Maybe it's increasing as ice cream sales increase over here in the upper sales areas per month. Perhaps shark attacks are getting higher, but nothing's really clear from this. So we're going to take a deeper dive into this data. So we're going to look at the correlation or how strongly two variables are related. So correlation can be positive or negative. So when it's positive, one variable increases and the other also increases, like study time and test scores. And when it's negative, when one variable increases, the other decreases, like stress and sleep. The more stressed you are, the less likely you are to have great sleep. So in order to do that, we are going to need functions that R doesn't already have. So in order to get functions that we don't already have, we're going to use the install.packages to install a specific package to use the functions that we want. So the package that we specifically want is called Dippler. And once we install these packages, we are going to have to pull them. We're going to have to say, hey, R, we want you to install these packages. So pull them from our library. So you're going to use the library function to summon whatever package you just installed. And then now we can use all the different functions that we want. So the one function we were missing was the select function. So we're going to look at the correlation, as I said above, and we want to select specific things within our data set. So we're using a function within a function. And then we are going to write, hey, we want shark data. And within our shark data, we want to look at shark attacks and ice cream sales. And since this is correlation, the syntax is different. If you remember before, we used the $ to get the columns and everything, but syntax is different since we're using a different function. I'm going to delete this line since I ran it down below, and we are going to run this. All right, so now we have the correlation between shark attack and ice cream sales. So for those of you that aren't too familiar with tables or haven't looked at them for a while, shark attacks, if we look at the row and then the column, the correlation between shark attacks and shark attacks is a perfect one, because if you correlate something with itself, they're perfectly correlated. If we look at shark attacks, the row, and then the column ice cream sales, the correlation is 0.53. So how do we interpret that number? Well, anything in like the 0.5 to negative 0.5 range, or if you have a number like 0.53, there's a range of correlations and what they mean, whether they're very strong or very weak, and I put them on the reference sheet for you all. So a correlation of 0.53, it's not a perfect one, but it's a pretty moderate correlation. So there's still something going on, and we don't really know what's driving the relationship between these two. So we're going to take a look into that. So we are going to look into variation. And for those of you that haven't taken a statistics course yet, it's just a fancy way of talking about how much something changes. For example, some people have a lot of shark attacks in a certain area and others just have a few. There's a lot of variation in these shark attacks. So when we try to predict something like shark attacks based on ice cream sales, we're looking at how much shark attacks change based on ice cream sales. So if we want to look a little bit more into the variation in those shark attacks, we are going to look at something called linear models, which are a way to find out more about the relationships between variables. So we create a variable, you can name it anything, called model, we have our arrow, and we're going to use the LM or linear model function. And we're going to put exactly what we want inside of those. So we're looking for the variation in shark attacks. So that's our dependent variable or the thing that's changing based on our independent variable. So we're going to use ice cream sales. And the way we create our linear models by using something called a tilde to say, hey, I want to know how much this varies based on whatever you put here. And then we have to highlight our data, which is shark data. And our summary is going to give us a brief summary of what's going on in our model. I'm going to run those two lines. And we get a whole lot of output, and don't be overwhelmed because we're not going to learn all about it today. But the most important thing that we're going to look at in this model is these little asterisks right here tell us whether or not our variable ice cream sales significantly contributes to the variation in our dependent variable or our shark attacks. So we can see these asterisks are letting us know that yes, it's significantly contributing to the variance or how much shark attacks change. But to what extent? So if we look down here and we're ignoring all these other numbers, there's something called the multiple R squared value, which can tell us the percentage of how much our ice cream sales contribute to our shark attacks. So this value you would multiply by 100 for a percentage, and you would say, okay, based on our multiple R squared value, 28.55% of the change or variance that we see in shark attacks is associated with ice cream sales. So moving along, just moving through the code a little bit quicker since we're running out of time. So our value of 28.5% of the variance being explained by only ice cream sales means that we have about 70% of variation that's really not explained by our ice cream sales. So if we wanted to look at another variable within our data set that may be contributing to this variance, oops, just moved along. Okay. Just gonna run this line again. It's just glitched on me. Then perhaps something else like temperature is actually affecting the relationship. So we're gonna run this line, which is just a model, and we're gonna add in the variable temperature by using the plus sign. And if we look at the same output, when we add temperature into the equation, we can see that our multiple R squared jumps from 25 to 53%. So 53.19% of the variance or changes in our shark attacks can be explained by both ice cream sales and temperature. So moving along, we're not going to take a break since we started a little bit late, but we're more than halfway through. So moving along, for this chunk of code, I won't be going over every single line with you because I just want to show you through this code that there's different ways you can visualize your data to get more information out of it. So I'm going to go ahead and press the play button here to run my entire chunk of code. And I want to show you that in R, you can create different visualizations to gather more information about your data. So in this code above, in my plot function, I created a much more complex plot than the one we had before. And I asked star, hey, for each of the points on my plot, could you make them vary? Could you make the color of them vary based on the month in which the shark attacks happened or the ice cream sales happened? So in R, you can change a lot of different things. You can change the colors based on a gradient, right? Or you can also change how big or small those points on the graph are as well. You can even change the font size and font type of the fonts you see on your X and Y axes too. But this visual gives us so much more information than our black and white scatter plot before. If I look at this visual, I can say, huh, it seems like in month 12 or December, shark attacks and ice cream sales are a lot lower on my visual plot. And that makes sense because not as many people want to go to the beach in December when it's cold, and not as many people want to buy ice cream when it's cold as well. So this visual gives us a lot of information, and that's just one thing that R can do. You can change these visuals greatly, and there are a lot of different graphs that you can use to visualize your data. So moving along, this is another chunk of code that I won't be going over line by line because it'll be used to teach you something instead. So we are going to look at a famous package called the Datasaurus package, and you'll see why it's called that in just a moment. But the reason why visualization is so important for our data is because if we just looked at our summary statistics, which means, oh, if I just looked at the mean, median, mode, standard deviation, and correlation of my data, then why do I need to visualize it at all? Well, this data set shows us why. So we are going to run these chunks of code that are going to give us those summary statistics. And we have 13 different data sets here. So each are called something different. And if we look at these summary statistics, they're almost identical for all of these data sets. And yet, when we visualize these data sets, if we had told ourselves, that's just the story, these are all super similar, basically the same, we wouldn't know the full story because when we visualize these, we'll give it just a minute. These are the 13 data sets on a graph. So they're drastically different and they tell us drastically different things about the data as well. I mean, here, obviously, a dinosaur doesn't tell us anything about the data, but that's just what they happen to look like when they're plotted. So the point that I'm trying to get across is the reason why we work so hard to visualize our data is that sometimes we, as human beings, our input is still valued. So when we look at data and we see a trend, we know what analyses to do based on that trend. So that's why visualization is so important. So just to wrap everything up, in these last chunk of code, in these last chunks of code, we are going to combine everything that we learned today. So we are going to look at something called personality data. I know a lot of you are interested in neuroscience or psychology since you are in Research Girl. So this is synthetic data, so don't draw any actual conclusions from what I'm about to show you. But we create our variable and we read our CSV file using the file path that we got. And then we're going to take a glimpse into that data. You could use print or you could also use head to see the first few rows of that data. So we just want to see what's in this data. So we have personality type, type A, B, C, and D, stress level, and executive function level. So for those of you that haven't worked with psychology research, I guess in general, we typically use scales to ask people how stressed they are, since we can't just ask them, we can't just assign them a number typically. Sometimes we have to ask them, hey, on a scale of 0 to 7, how stressed are you? So that's why you see values like that here. And executive function is how well things like working memory, recall, and planning are working as well. We have this term called executive function for all those different things. And you can also use a scale. A scale is one way to measure executive function if you don't have an active task to measure that as well. And so that's what we have going on in our data set right now. Me personally, I'd be interested in how personality type and executive function might be related to stress, or perhaps another way around, how stress and executive function are related to personality. So in order to look at this data, we are first going to visualize it. And we can do that using the ggplot function. So instead of using the plot function, we can use ggplot to add a bunch of different elements to this graph. And so within it, we're going to define what our data set is. And then we're going to add X and Y labels as well. The syntax is, or grammar of the code we're writing is a bit different from when we use the plot function. So we're going to use the function within ggplot AES for aesthetics for our X and Y labels. And I want the color of the plots to be the personality type 2. Jitter, just to make sure that our little dots in our plots don't overlap on each other so that we can see the data better. And then we're just going to add our title an X and Y axes, and we already said we want the color of the points to be our personality type, and you'll see why we do that in a minute. And at the end of ggplot, you can add a theme. There's different themes in R you can look up, which just means different font sizes and styles as well. And so I'm going to run this chunk of code. And as we can see here, we have our scatter plot of stress levels and executive functioning levels as well. And our personality types are the colors of the points. So if I look at this and I say, are there any patterns or obvious trends in the data? Well, I can see that our type A personality types almost seem to be clustered in this upper left-hand corner, which means they tend to have higher stress levels and lower executive function levels. And if I look at, all these green dots kind of seem to be clustered as well. Personality type Bs seem to have a lot less stress and higher executive functioning levels. So I'm already thinking, okay, there might be a trend where type As may be more stressed and therefore they have lower levels of executive functioning versus type Bs, maybe less stressed and have higher levels of executive functioning. Maybe there's a relationship there. And so what we're going to do now is we are going to create a linear model to look into that relationship. So we loaded our personality data here, and we're going to look at the first few rows again, just to take a glimpse. Yep, personality type, stress, executive functioning level. But the thing is, when I'm looking at the data here, there's this little NA value, which means that when someone was inputting the data, perhaps somehow it got rid of one data point, perhaps someone didn't want to answer a question about their executive functioning level, maybe they were taking a survey, they forgot to click on something. So since our linear model is based on calculations, we need to get rid of this NA. So there is a little function called na.omit, and I'll write it right here for you all to see. And what we are going to do is we are going to rename our data set personality cleans. So we're cleaning our data set and we're getting rid of that NA in it because it might disrupt our analyses. So I'm writing a new name for the new clean data set, and I can run that and that NA will disappear. Yep, it's gone now. And what we can do now is we are going to jump over that line right now. So looking at this line, what I'm doing here is that we know that our linear model is based on calculations. So if we have personality types like A and B, well, our linear model can't calculate A and B regarding other, when it's being calculated with other numerical values. So we have to change our A and B to be numerical as well. So R might assign a value of 1 being A, 2 being B, and then we can calculate based on that. So what we're doing here is we're saying, okay, within our personality data, we're looking at the column with the money sign, personality number, or personality type, and then we're going to convert it to be numeric using a function called as.numeric. And we're going to insert our column in here. If you remember, personality data, we're going to look at the column with the money sign. And moving on from there, we can look at our linear model. So in this case, we're going to say, okay, how much does stress vary based on executive function level and personality type? So stress goes here. And then since we're looking for the variation in stress, we're going to put the tilde in and our two other columns here. And we're going to define the data type as well. And then we're going to look at a summary of that linear model, and we'll be done for today. So I am going to run this entire chunk, so I don't remember which lines I ran already. We have the same type of output as before. So if you see these asterisks, it means that these two variables significantly help us predict the variation in our stress level. So executive functioning and or function and personality type do. and we're only going to look at our multiple r squared. So we're going to multiply this number by 100 to get the percentage. So 23.7 of the variation or the change in our stress levels can be accounted for executive function level and personality type. So overall, that's not a huge number. There's other things that are driving the variation or change in stress level. Like I said, this is a data set I made on my own for learning purposes today. So I wouldn't draw any actual conclusions on your type A versus type B friends based on this data. But that concludes the code we will be looking at today. I will just share a few more slides on learning resources and we'll be done for today. So I'll go ahead and stop share and I'll share my screen again. All right, so slideshow. Okay, so what did you learn today? You learned about the R syntax and R Studio interface. If you remember, source is where we wrote all our code today. Console is the other panel where you could look at the output, but since we had looked at a notebook today, we had all our output right underneath our code. You also learned about how to perform basic operations in R, including addition, subtraction, multiplication, and division. And you learned about vectors, or if you remember, our list of all the same type and how to create your own data frame with those lists too. And last but not least, you learned about scatter plots and statistical modeling. So scatter plots were used for visualizing our relationships between our variables and modeling linear regression as well. So out of today's workshop, out of all the workshops I've attended as well, when I leave a workshop, I don't necessarily remember all the syntax, all the small rules that I learned in the workshop. You might not remember any of it at all, but the whole point of these introductory level workshops is to say, hey, this is a free resource, this is accessible to me, and this is something that I can understand as well. It's just to get an introduction to this programming language and see that it's not as far-fetched or complicated as it might seem sometimes. So to build upon your skills in R, there are actually a ton of free resources. Learning R or a programming language is like learning an instrument or even a sport as well. Even if you put in 30 minutes twice a week, that'd be super beneficial to your learning. And so I and a few other colleagues created a website where you can look at free resources to continue your learning in R, which you can go ahead and copy down the website here. I also have it in the R reference sheet, or use the QR code here as well to look at the website where I provide free links to resources where you can continue your learning. And even if you want to learn Python or web development, there's different links there as well. So that is all I have for you today. I will be sending Mia a link to a survey to give me any feedback about today's workshop so I can improve for future workshops. But there's no official certificate for this workshop, but through the links, if you do want a certificate, there are paid courses if you want a certificate for learning in R or advanced things as well. But the ones I have linked here, they all have free options. So highly recommend that to continue your learning as well. If you're part of a university, LinkedIn Learning has a lot of free courses in R, and a lot of the times your university will provide you with a free account. So that is all I have for you all today. So I will stop sharing my screen. I hope today, remember, you probably won't remember all these grammar syntax things when it comes to R, but I hope today what you take out of this is that R is something accessible to you and that there are free resources to continue your learning. All right,
Thank you
thank
so
you,
much,
everyone.
Stephanie.
Mhm.
Thank you. And thank you, everybody who attended. I just want to mention before we hop off the call that there will be a recording available in case you missed anything or you need to go back. and see some of the code. So that will be sent out. And also we're going to have future coding workshops in Python, C++, Java, and MATLAB. So keep an eye out for those registration links as well. But thank you guys so much. And I hope you have a great rest of your day.